All right, good afternoon, everyone. It's a long week, but we're almost there. We're going to be starting the next unit today, which is Unit 4, which is also dealing with quadratics. But Unit 3, which we just finished, dealt with quadratic functions, and this unit deals with what we call quadratic equations, and that's a different beast. It's similar, obviously, in that it involves quadratics, but equations and functions, although they are connected to each other, are different. The exams have been marked. I'm overall pretty happy with the marks. I would say that this, if you were struggling a bit with the last unit, this unit might be a little difficult as well. But this is maybe the most important unit in Math 20-1, this one and another one. And again, I don't say this to you to try to put fear into your hearts. I'm saying it to you to try to make you aware of what my expectations and to motivate you. It's very easy to fall behind in this unit. The level of algebra all of a sudden increases another level compared to what it has been doing. So if you find yourself confused or you don't know what's going on, you have to ask those questions right away. You can't let it get away from you. So today we're going to be looking at what are called graphical solutions to quadratic equations. For the most part, everybody, this whole unit is about solving quadratic equations. It's about solving equations. And we're going to be looking at least 4 different ways that we can solve quadratic equations. Today we're looking at how we can solve them using graphs. So we're going to be relating the x-intercepts of the graph of a quadratic function to the solutions to the corresponding equation. Now, this is important. You might think terminology in math is not that big of a deal, but it is very important. When we talk about where a graph crosses the x-axis, which is a way of saying when we talk about x-intercepts, another word for x-intercepts is zeros, but we only use those phrases, x-intercepts. Josh, are you with us? We only use the phrases like x-intercepts or zeros when we're talking about a function. And although I haven't explained to you the difference between a function and an equation yet, I'm telling you right now that if you have a function, which is basically a graph, you can talk about the zeros of the function. You with us, true? Okay. And the zeros of the function, which is a graph, are the same as the x-intercepts. However, when we talk about an equation, the words we use are solutions or roots. So when I give you an equation and I ask you to solve it, and I'll give you a very simple equation to solve. Everybody should be able to probably solve that mentally without having to write anything down. The answer is 5. Because algebraically you've been taught that what we could do is you could add 10 to both sides and then divide by 2. So when I say solve this equation and you say, okay, now what? Well, you're done. X equals 5. But what you have found is a solution to the equation. Or what you have found is a root of the equation. So from now on, when you're given a question that says determine the roots, what it's saying is what are the solutions to the equation? But the word roots or root and the word solutions or solution are applied to the word equation, whereas zeros and x-intercepts are concepts that apply to a graph of a function. So we're going to be solving quadratic equations. By the way, everything I said to you about this terminology is true whether the function or equation is quadratic or anything else. You know, I could, if this were a Math 30 course, we would have a lesson in Math 30 where we would relate the x-intercepts or zeros of the graph of a trigonometric function to the roots or x-intercepts, to the roots or solutions to the corresponding trigonometric equation. So it doesn't have to be quadratic. This terminology is still valid. All right, so we're going to be solving quadratic equations graphically, and then we're going to be talking about the fact that quadratic equations may have two solutions, they may have one solution, or they may have zero solutions. Okay? So to begin with, here's the terminology officially. When I talk about something like a quadratic function, it has a y in it. And if you take a look at these two things, I'm going to highlight them both for you. I'm going to highlight one of them in yellow. That's not yellow. I'm going to highlight one of them in yellow. I'm going to highlight one of them in cyan or teal or blue, whatever you want to call it. Except on yours, you do not have what I have in blue, correct? You have 0 equals or equals 0. Okay. So what you have, I always do that, I copy and paste. Let's go equals 0. So help me out here. This is what you have on yours. Okay, good. So that's the one I'm going to highlight in blue. And I'm just asking you to notice the difference between those two things that I've highlighted. And there's some similarities too, aren't there? And what we would say is that y equals x squared minus x minus 6 is a quadratic function, and x squared minus x minus 6 equals 0 is the corresponding quadratic equation. Okay? But if there's no y and it's equal to 0, then it's an equation, and if there is a y and that's what it's equal to, it's a function. Now, if you look at what this says next, it says to solve any equation means to find the value of the variable that makes the equation true. Question? Okay, I wasn't sure. So imagine I said to you, solve the equation in blue. That would mean you would have to find a number that you put in for x that makes it true. That's pretty difficult, isn't it? You can't rearrange that equation for x. You don't know how. But you might start trying to put numbers in like 1 or 2 or 3, and sooner or later you would come up with a solution. That's our whole goal today, is to figure out how to determine values for x that make an equation true. And again, those solutions are called roots of the equation. So as a warm-up, we're going to use our graphing calculator to find x-intercepts of a function. Funny, I hear this zzz, zzz, all the graphing calculators coming out of their cases. So we're going to enter that into our graphing calculator, probably go zoom 6. I'll tell you right now that the x-intercepts will be integral numbers. What that means is they're going to be integers. So we could probably determine them by looking at our table or just looking at the graph, but I am going to remind you of how to find them on your calculator with the 0 function. So I'm going to enter y equals x squared minus x minus 6. I'm going to go zoom 6. And I'm going to remember that when I go to my calculate menu, this is actually kind of interesting. When I go to my calculate menu to find the x-intercept, I choose 0, number 2, which is called 0. And that certainly makes sense because I've told you that x-intercepts are zeros. The reason why they're zeros is they're the value of x that makes y 0. Okay. Calculator open again. So I'm going to find my 0. I hit enter. I'm going to go to the left of that first one, hit enter. I'm going to go to the right, hit enter, and I find the first x-intercept is at -2. stealing candy from a baby. He didn't even look at me. He didn't even see me. It's so easy. Have you found the other x-intercept? What is it? 3? I think it's 3. So that's pretty easy. The x-intercepts are at -2, 0 and 3, 0. I suspect that many of you didn't write -2, 0. You just put -2. Am I right? Yeah. And that's fine, but I think this is a better way to write it. If you are going to just put -2, then you should write that. You shouldn't just put a number. Okay, that's pretty easy. That's something from the last unit. Number 2, take these two x-intercepts. Now, I've written them in the blanks. You can do the same thing. Take each of these two x-intercepts and put them in for x in the corresponding equation. And I want you to pay very careful attention to the mathematical statement in number 2 and the fact that it says x squared minus x minus 6 equals 0, and that's different than the mathematical statement in number 1, which said y equals. In number 1, the statement was a function. In number 2, it's an equation. So what we're going to do is put -2 in for x. And we're going to simplify the left-hand side. It's good to put a set of brackets around any number that's being substituted in for a variable. -2 quantity squared is 4. Minus -2 is +2 minus 6. And we end up with 6 minus 6, so we get 0 equals 0. Let's do the same thing over here. 3 squared minus 3 minus 6. This is supposed to equal 0. We get 9 minus 3 minus 6. Well, that's 0 equals 0. What we notice is we get a true statement. -2 makes this equation true. 3 makes this equation true. It's not a coincidence, and I'm going to explain why this is the case. But what I am teaching you, and in fact what is maybe very obvious to a few of you, is that the x-intercepts of the function have to be the same numbers as the roots of the equation. Why? Why is that the case? So we're going to explain this now, or I'm going to. You can choose to write this down or not. When you find x-intercepts, you change y to what number? 0. Right? So when you find x-intercepts, you change y to 0. So finding the x-intercepts of y equals ax squared plus bx plus c means solving zero equals ax squared plus bx plus c. Except that you don't know how to solve this equation yet. Algebraically, if I gave you 0, if I gave you this equation of, let's be specific here, of x squared minus x minus 6 equals 0, and I said rearrange that for x, you have no clue how it can be done. You just haven't been taught that yet, and it's not simple. There's a lot of ways we can do it, but it's not simple algebraically. So instead, what you do is you say this. If I'm asked to solve that equation, then what I'm going to do is pretend that this is y equals, even though it's not, and I'm going to find the x-intercepts of that on my calculator because I know the x-intercepts of that function are the solutions to the equation I'm asked to solve. So you turn it into a function because the x-intercepts have to be the same as the solutions. By the way, this will serve you very well in other courses and other units. It doesn't have to be quadratic. If I said to you, solve four log x equals 1, you don't know what that is, do you? Log x? Well, what you could do is you could say 4 log x minus 1 equals 0. And that means you could imagine that this is y equals 4 log x minus 1. And if you can enter that in for y and find the x-intercept, you found the solution to the equation. Let me show that to you. Y equals 4. Oh, look at that. There's a log key. Log x, better close the brackets on that, minus 1. Zoom standard. Hey, there's an x-intercept. Can find the x-intercept. Left. Right. That's the answer. Now, I want to point something out to you. You just solved a Math 30 equation without having any understanding of the math at all, right? But I will demonstrate to you that that is a solution. There it is. If that's a solution, then when I take 4 times log of that number, I have to get 1, right? What just happened there? Oh, I have to go 4, I believe I have to go 4 log x, I think. Wow, it's not working. I'm sorry? I didn't put, oh, I put ln. That's my mistake. So it's, let's change this. Ln and log are similar, and I use ln a lot. Don't worry about what they are. There we go. So it's log. Let's see what I get. So that's the answer. So I'm going to try this now. I'm going to go, here's my x. I'm going to go 4 log of that number. If I can get it, 4 log of that number. Okay. Sorry. It can be a trigonometric equation. It can be a quadratic. It can be a polynomial. It can be a logarithmic. It can be exponential. It can be anything. That's good candy. Okay, so we've got the explanation down. We're done. Let's try some examples. Solve this equation. Well, again, I want to explain the underlying thinking here. You can't solve that equation. You don't know how to solve that equation. So instead you go, well, you know what? I'm going to imagine that it was a function. And I'm going to find the x-intercepts of that function using technology because I know the x-intercepts of the function are the solutions to the equation. That's all you have to do. I go through that because I want you to understand that there's no y in the question. We made that up. So y is equal to 3x squared minus 10x plus 8, zoom 6. If I had to guess, it's 1 and 2, but I don't think a guess is good enough. We should zoom in on that little thing. I cannot remember. Have I showed you how to use zoom box? Okay. It's the coolest zoom feature ever on your calculator, I think. Let me grab this and tell you that what we really want to do is we want to look here, don't we? Well, what I just did, I'm going to do on my calculator. I'm going to draw a box around that so that it zooms in on that box. So I choose zoom. The first option is box. And there's a little blinky cursor that I can move around. I'm going to put it in the bottom right-hand corner of my box. I could put it in any corner I want to. But I'm going to start there, and when I hit enter, now when I scroll around, it stretches like a piece of elastic the four sides of that box to any box that I want. And now, when I hit enter a second time, oh, that's better. I can see things better now. I can use the 0 function of my calculator. Second calc, 0. Left, enter. Right, enter, enter. It's going to be 1.33. Now, I know I've told you I don't want you going math, enter, enter. But that's not the point today. We can do that. How many of you know 1.3 repeating is 4 over 3? Okay, then you can do that. If you don't, notice it says x equals right now. So when I quit out of here, if I just hit the x key and go math, enter, enter, it's going to tell me that it's 4/3. Have you found the other x-intercept now as well? Is it 1? 2. It's 2. So quickly, I'm not going to do this for all of them. If you go to 0, then you go to the left of it. I mean, I can see it's 2. And there's other ways to verify that it's 2. It's 2. So when we are asked to solve this quadratic equation graphically, there's no work to be done. You can't show any work. It's x equals 4/3 and x equals 2. I don't want to do this every time we do one of these questions, but I don't want you to lose sight of the fact of what that means. What does it mean to say x equals 4/3? It means if you put 4/3 here and here, you'll get 0. Okay, we can check it out. And I'm not going to do this every time. Brackets, 4 divided by 3, end bracket. I guess I want to multiply out in front 3 times that squared minus 10 times in brackets 4 over 3 plus 8. We get 0. What we're finding is numbers that make the equation true. All right, what about 8p squared plus 18p minus 5? Well, I'm going to do a lot less talking and a lot less writing here and just cut to the chase. You need to graph it first. I hope that there's nobody in the room you've run into a brick wall because there's no x in the equation, that it's p, right? You're just imagining that it's x. It doesn't have to be x. So 8x squared plus 18x minus 5. Always go with the zoom standard first. It's your safest bet, which I didn't do. I just went graph. So zoom standard. We're learning a bit more about the calculator and getting more practice. Do you see that the two lines that I have here that are the sides of the parabola are really steep? That's not ideal to find zeros because it's hard to go left and right of the x-intercepts. So I'm going to adjust my window settings to lop off the wasted space on the left and the right. And I'm also going to adjust my window setting to see if I can get that vertex into view. And those two things will make the parabola more U-shaped and less V-shaped. So I guess I'll go from -6 to 2, and I'll go down to -25. I don't know if that's going to do it or not. That looks pretty good. Now I can find the two x-intercepts. I'm assuming you're doing this as well. -2.5. And 0.25. If you want to leave those in decimal form, that's fine, but in fraction they are -5/2 and 1/4. You could leave them in decimal. Just baby steps in terms of a little bit more involved here. You have to zero the equation to make this work. And that's what it's called when you move all of the terms of an equation to one side and leave 0 on the other. You're zeroing the equation. So this is 9x squared plus 7x minus 2. I'm going to give everybody a couple of minutes to enter that into your calculator and find the values of the two x-intercepts. Is yours different? Oh, your calculator? You can go get it. So I'm guessing it's this battery that needs to be replaced. You're going to have to replace that battery. So you have to get a screwdriver and take that off and then find out what battery it is. They're all different. So in the meantime, I got a calculator I can lend you. Excuse me. Put up your hand and then put it down if you've got the answers. I just want to know who's got them. Okay. -1 and 2/9. 0.2 repeating. 0.2 repeating is 2/9. You'll notice I was able to determine those values like some kind of magical wizard without looking at the graph, and that's because I know how to do it algebraically, which is something you're going to learn eventually. So those are the two x-intercepts of the corresponding function. Those are the two solutions to the equation. Any questions with C? Right? give you a couple minutes to do this. You have to zero the equation, so you're going to have to move both of those terms over to the other side. Then you can worry about graphing the corresponding function. This is a weird one. How many of you have it already, by the way? Okay, very good. So I know what the answer to this is, but I'm going to do it up here in the same time that you're doing it. Can I ask you guys a question first, though? To how many of you is it the case that you don't actually have to write that down to know that that's what you're going to put into the calculator? You know, I mean, if it were a written response, we would want to make sure we write that and explain what's going on, but I would never give you this type of solution as a written response. I wouldn't expect you to solve them graphically. So we have 4x squared minus 20x plus 25. Let's go zoom standard. And I see it's right there. Now, to be fair, could this parabola cross the x-axis? Might it go a little bit below the x-axis there? Maybe. I mean, I don't know. I do. And the answer is no. But just looking at it, if I didn't know what the equation was and I didn't know something you're not aware of, I would be unsure. So I could do the box thing and zoom in. I like the box thing because you can get pretty good detail there. That might be too much. There we go. Whoops, I forgot to hit enter. I really like the box thing because you can really specify where you're looking. All right, so enter. Maybe it goes below. Maybe I just can't see it. Well, I'll save you the suspense. If you keep zooming in, you'll discover it doesn't. And you can kind of convince yourself of that by trying to find a 0 right now. And this is kind of weird. I hope it's going to work. Normally, when you go and you use 0, left and right are on opposite sides of the x-axis, aren't they? Like left might be below, right might be above, or left might be above and right might be below. But I don't know that I'm getting below. I don't know. So I'm just going to try here and here and hit enter. I don't know if it'll do it. I think it should. Yeah, 2.5. And there's no way for you to convince yourself right now of this fact, but this parabola is in fact just touching the x-axis and coming back up. Algebraically, you don't know why that's the case. I can look at this and tell you that that's the case. But any questions with B? Is that B or D? Whatever. Any questions with this one? Okay, so solve each quadratic expression, writing your answers to 2 decimal places. I don't know if you noticed, but every single solution to every one we looked at so far was a nice tidy number or fraction. And we could convert them to fractions. Let's see what happens when we solve this one. So being able to solve them on your calculator is just the first step in what we're learning today. Don't sit back and go, okay, I get how to solve this. There's more involved. Minus 10x, minus 9. Let's go zoom 6 because we had that zoom box thing going on. I'm going to adjust my window settings. I'm not too happy with those really steep lines. I'm going to shave off the left and right side that's not being used. And I'm going to increase my negative y value. Well, I'm going to decrease my negative y value to a more negative number. Let's go negative 2. Now let's go 3 to 8. Negative 3 to 8. And we'll go negative 30. I don't know. That's pretty good. So I want you to follow along carefully here. I know that many of you already have the answer, but we'll do this one first. Enter, and where did I go to? 1, 2, 3, 4, 5, 6. Oh, I'll go to 7. So there's one of your answers, okay? 5.77 something. And it said to 2 decimal places, so I guess 5.78. Look up here, please. If I go to my home screen and pull up x, and I try to convert this to a fraction, I'm out of luck. The calculator will not convert it to a fraction, not because it's not capable of doing it, not because of my calculator. It's impossible to write this answer as a fraction. It's an irrational number. Okay? So that's one of our answers, and then we can find the other one. Let's go negative 2 to 0. By the way, if you can read the approximate x values, it's quicker to just enter a negative, a left x and a right x rather than scrolling. And the other answer is this. It's no coincidence that they have the same decimals. Okay. But those are our 2 answers. Good? All right, I'm going to give you a couple minutes to solve this one. Put your hand up and down if you've solved it already. Is it the case that when you look at the graph, you pretty much have solved it? So this particular graph, and we could, you know what we could do? We could graph this, just give me a second. We could graph this by completing the square and using what we learned last unit, but I don't think it's necessary. Give me 1 second, Seamus, and then I'll be right with you. So it is 2x squared minus x plus 12. Go ahead, Seamus. It did what? So look in the top right corner of the screen. Is there a little line buzzing around? No? Can you check very carefully, go to y equals, and see if you actually entered exactly what I have here? And it's minus, you didn't hit the negative sign? Just give me 1 second. Oh, well, no, that's okay. I want to be careful. There's nothing wrong. I want to be careful here because everybody's calculator is going to look like that, right? Does that mean the parabola doesn't exist? See, I know what it looks like because I'm looking at the equation. Does the parabola open up or down? Up. What's the y-intercept? What's the y-intercept of this function if we graphed y equals that? 12, right? So it must be up there somewhere. And think about it for a second. If the y-intercept is 12 and it opens up, it's just way up there. I didn't realize I was giving you guys a really tricky question. Let's go up to 25. So you went zoom 6 probably. And then you're sitting here looking at this. So let's try looking out further. So what you could do, I suppose, is go zoom out. I really am not a fan of zoom in or zoom out. Because you're taking the control out of your hands and you're saying, calculator, zoom out. But if you do that and you hit enter, oh, there it is. So that corresponding function does not have any x-intercepts. So what do we put for an answer? This is maybe the first time you've encountered this with an equation. The answer is there's no solution. There are no roots. If we wanted to have fun with a grade 10 class, we could throw this equation on the board in a grade 10 class and say, okay, here's what I want you guys to do. I'll give you a few minutes to do this. I want you to try different numbers for x, and I want you to find a number for x that makes that equal to 0. And then we would just have a laugh because it's not going to happen. It's impossible to happen. Not everything has an answer. Okay, 8x squared minus 3x minus 5. I'll give you a couple minutes to do that one. You'll notice I said 8x squared minus 3x minus 5 equals 0. I think we're going to get some numbers that we could put in fractions here.
When there's only one x-intercept, does that mean that that's also the vertex?
Yes. Okay. Has to be. It's the x, it will be the x-coordinate of the vertex. Yeah, definitely. Are the answers here 1 and 0.625? And 0.625 is 5/8, I think. I think you get the idea here of how to find these solutions graphically. So before we move on to the next part of this, any questions? The question was just posed to me, if there's only one x-intercept, does it have to be the vertex? And the answer is yes. And that x-intercept will actually be the p-value of the vertex. Okay, so we can skip D. Because I think you get the idea. Summarize the 3 different situations that can arise when solving a quadratic equation using the x-intercept approach. Well, you know what I could have done here, everybody, with this question is I could have said, summarize the 3 different situations that can arise when solving a quadratic equation. Because whether we use the x-intercept approach or any other approach doesn't matter. The graph of the corresponding function might have 2 x-intercepts. It might have 1 x-intercept, or it might have 0 x-intercepts. So, this is the point of this question. ax squared plus bx plus c equals 0 might have 1 solution or root, 2 solutions, or 0 solutions. And there's a way for you to tell that by looking at the equation, but you don't know what that way is yet. There's a way to look at the numbers and know whether there's going to be 1, 2, or none. And when you do learn the algebraic methods here, it's going to be a very powerful tool. This graphing calculator will get a little clunky after a while with certain processes. Okay, final question. Oh, a word problem, because, you know, who doesn't want to do a word problem on a Friday afternoon? two numbers have a sum of 46 and a product of 396.75. What are the numbers? What is this doing in this lesson? Well, it turns out to solve this, we're going to create an equation to describe the relationship between the numbers. And it turns out that when we simplify that equation, it's going to be quadratic. So the first thing to note is what we're going to have to do is define the two numbers. One of the numbers can be x. Now this is subtle, okay? When we solved word problems, which means it's slippery to wrap your head around. When we solved word problems in the last unit, we could use two variables because we were talking about functions which had x and y. We're talking about an equation here, so we don't have two variables. We have only one. If one of the numbers is x, then what can we call the other number? And the hint I will give you is what I'm going to highlight, which is that. The numbers add up to 46. One of the numbers is x. What should we put for the other number? So how many of you have an idea? What will we put, Dua? 46 minus x. This is the other number. Now, I will admit that your textbook, and there are probably some Math 20-1 teachers that would introduce another variable only to get rid of the other variable as soon as they could. So I think it's better here if we don't introduce another variable. We just say, well, look, if x is one of the numbers, then the other one must be 46 minus x. That's the setup. So what's highlighted in yellow allows us to define these variables. Try that again. What is highlighted in yellow allows us to write out these statements. What I'm going to highlight in blue allows us to write out this statement. It says the product of the numbers. Product means multiplication. So if I multiply the x and the 46 minus x, I get 396.75. Well, let's expand this to get 46x minus x squared equals 396.75. So I've used the distributive property here to multiply the x by the 46 and the x by the negative x. Now there's a little bit of business that I think is valuable if you follow it carefully and understand it. It's quadratic, yes? Okay, I have to zero the equation, right? I can zero the equation by moving everything to the left side or the right side. I'm going to zero the equation by moving everything to the right side. Does anybody know why I've chosen to move everything to the right side? Right. I like positive x squareds. If you did it the other way, you'd get the same parabola, but it would be upside down. The x-intercepts would be the same. But it doesn't matter. I would prefer it to be x squared minus 46x plus 396.75. Now, I know, and Isaac, I think you were one of the people, when we were solving things graphically, I know there were people that would rather solve it algebraically because it gets confusing with the zoom settings. This might be one of those ones that you'll wish you knew already how to solve this algebraically, because that 396.75, that's a big number. That's the y-intercept of this function. But we also know it's got to cross the x-axis because there's an answer to this question. So let's enter it, and then we can talk about the window settings and the zoom settings. What do we have? X squared minus 46x plus 396.75. So here's my thinking. I don't think Zoom Standard will do it. I can show you that it won't. I don't think it's really going to be helpful. Yeah. My thinking is x is one of the answers to this question, right? And it's a number. Look at what we wrote. X is one of the numbers. Well, it's got to be some number between 1 and 46 because they have to add to 46. So I'm thinking I should set my window setting up to go up to, well, 46. The negative 10 doesn't matter. Let's start with that and see if we can see some x-intercepts. Oh, there we go. Sorry, I got a little excited there for a second. But you can, it's very steep though, isn't it? So I'm going to shave off the left and the right, and I'm going to bring the vertex, which is who knows where. I want to bring it more into view. Right now, I went up to 46, so let me show you what's going on in my head. I'm saying this is 46, so maybe that's 25. I think if I went from 10 to 40, that would be good. And I don't know, this looks like way down there, doesn't it? Like negative 100? I don't know. We can always change the number later. So I'm going to go 10 to 40, and I'm going to start down at negative 100. It's way, way down there. Like negative... Oh, I never changed it, I guess. I thought I did. Oh, there we go. That's better. I can find those x-intercepts. And I would like you to find them, please. I'd like you to find both of those x-intercepts. See, even I don't say that like I'm invincible or something, but even I'm having a bit of a struggle here in getting the cursor where I want it to be. I really just want to do it algebraically, but I wouldn't do that to you because you don't know how to yet. And by the way, I would increase my Y max on my window settings. Then I've got some room to see what's going on. As I've said before, I think it's the case you can hold your key, but I can't. So one of them is 11.5, and one of the solutions is 11.5. And what do we have here? I went up to 40, so I'll go 30, 30, yep, and 39. And one of the solutions is 34.5. And I want to explain something here because some of you are going to, at the end of this explanation, go, who cares? It doesn't matter. It does matter. This equation has two solutions for x. Okay? X can be, in the equation, 11.5 or 34.5. My point to begin with is these are not the two numbers. This is x. X has two possible values. x can be 11.5. The other number would be 46 minus 11.5, which, okay, happens to give you this. All right? But there are going to be cases where that's not the case, where you genuinely are going to get a set of numbers here as a solution and a different set of numbers here as a solution. So there's actually two answers. The first number is 11.5 and the second is 34.5, or the first number is 35, 34.5, and the second is 11.5. And I know that you'll quibble and say that's the same answer, and I will agree. But it won't always be the same. You genuinely, the question branched off into two different answers. And they happen to both be the same. That's okay. If you're confused by that, don't get overly worried about it. It is confusing. We'll see more and more of these situations later. So on page 215, practice problems 1 through 9 would be a good smattering of what to do here to make sure you're on task. And